There used to be a time Feynman. And don't get me wrong, I still one of my favorite pitches ever will be the Mayan astrologists and the Mayan astrologist kids. By far, two sticks. One of the best demonstrations to get the banana monkey. But in here, I wanted to take the notation of let's deconstruct this problem. What are we looking at? Anybody here? I'm going to give you a second, some lockdown math. Maybe, hell, I'll build the web page for it to deconstruct it. Some, what do we got down here? It's not just lockdown math, it's something different. It's Pavlovians. I forget what it was, there was another term in front of it. But that's going to be on my roadmap here in a minute as well. Setting up a lockdown math stone mill page, right? Solomon Stone Mill, lockdown math. And start to actually figure out how to do the computer engineering lines, math, waves, simple block drawings. There, it's not very practical, it's very practical there. It's just not super useful comparatively to the real shaking hand danger videos that you'll wind up making, like on that web page. Because getting it to the web page is easy, starting to figure it out. But let's talk about some top and the bottom stuff here of what Feynman might be talking about here with this integral. What is the first thing you see? It's the first thing you think of. The first two things you think of, and try to keep them as far away from each other as possible, the two things. I'll let you think that through. Okay. So, when I first looked at this problem, I saw two different states. Really, I saw the first one first, which is probably backwards. I saw gravity first. I saw the integral of force and fx and dx. So this is thinking about a jump. Let's jump off the ground and make one indicator. I mean, you need jumped, but do you really know what number that is? I mean, did you have a ruler under your ground or some high-speed camera in the way to track that? No. So we're going to need a way to track that, and that's the devil in the details to the derivative of those details, right? And in the sense, this is a time sequence, but it's really the height sequence here. We're just taking a number of Feynman kids jumping when he says jump. Do an integral fx dx equals double integral ab gx, or g parentheses x dx. Most kids are going to do that social contagion. And like I said, you shouldn't, some of these people can be pretty null statey about it, but on the other side, you got to take what information they provided on the large scales. Feynman's a huge name, been dead for a long time. It still comes up solid. Even if the new teachers do it, they're utilizing Feynman as a armor plate in this integral. So it's not exactly right. Feynman's going to be more based in the extraterrestrial than he's going to be based in the gravitational throwing a ball, but he's good enough to throw a ball and figure out, or jump, and figure out what's the integration of all those jumps on their value over time. Ft, Fx, we were doing it earlier. And that's the derivative of all the second jumps. We're saying Fx is the first jump on the integral x, y, and z, and that's multiplied by 1 or 0 and 1 times, right? So that's why the math looks that way. It equals a double integral. That means not only was like that first step, but very classical. Somebody will ask you, why aren't they the same thing? Well, in the stone mill, they are the same thing, but it may differ over 52. If the operation only lasts this long, and again, orbitals and things like that are going to come around in cycles, high and low of that eclipse, starting to total in the other eclipse. So eventually we'll run out of total eclipses because of the way the Earth moves one rotation in a day, the Moon a month for one rotation, and eventually heat death will take that out. But the approximation between that Lagrangian right there, or Laplacian, gives me some kind of wave function. If here, then there, and you're not looking for 7. You're looking for the ranges of how it's supposed to start in the morning, the integration of the day before, into today, about how that processes through the clock in, how high you can jump, right? Because this is the integral A to B, not A to B. There would be the rate of a ball falling. And so people, make sure you take a look at that. You really deconstruct this. And here where gravity, little gravity, 9.8 equals x, is what you would have deriven from this out of all those calculations, which you don't know. Here we just have a derivative x of how many test systems you're going to have. 100, 1,000, a million. If you integrate those tests, you'll have this same jump thing, and why, hopefully me one day or somebody else, when I'm starting to hit you with this stuff and I'm like, you need to get over there now. It means something.